we're going to talk about all different kinds of factoring. And we're going to talk about these a lot throughout the chapter. And you've seen most of these methods of factoring before. But essentially, factoring is going to be just the opposite of what we were doing. Kind of like if I multiply 2 by 3, if I divide 6 by 3, I can get back to 2, right? So you're kind of undoing the process that we did in chapter 5 and going backwards. So for instance, if I had a problem where I had 3 times 6x plus 4. This is a problem like what we did last chapter, right? We would take 3, we would distribute it, and that would give me 18x plus 12. But now what we're going to do is we're going to be given this as our beginning point, and we're going to go backwards to figure out what are the two things that would multiply to get me that. Okay? And there's a lot of different kinds of factoring that you've done throughout the years, and we're going to continue to see those again. We're going to kind of break it up into different days. But for this factoring, the one I just gave you here, this would be a GCF type of factoring. Because what I would do is I would look at these two terms, and I would say, what is the GCF? And that's always going to be our first thing. What is the GCF of these two terms? Can I take something out? And if I can take something out, that's always going to be our first step. And so we're going to look at some problems like that today. The first thing that we're going to do, just because this is kind of the way the homework is set up, is we're not going to actually do some factoring on some of these. They're going to give us a couple of terms. There's no plus or minus or anything like that. And we're simply going to find out what is the GCF. Find the GCF of those two terms. And typically it'll be 2 terms. I mean, it could be 3 terms or however many terms, but 2 is the most common way it's going to be written. We don't have any addition or subtraction sign in between here. We just want to find out if these are my 2 terms. The first thing we're going to look at is what's the highest thing that goes into both 4 and 24. Well, 1 goes into everything, right? 2 goes into both of those, okay? But 4 is the one that we want, because 4 is the highest number that goes into both 24 and 4. So the first thing we would say here is 4. Okay, when we look at a term, the coefficient, GCF. Now, as I look at x's, or a variable, okay, this one has 3 x's, this one has 2 x's. And kind of the way I think about it, or at least the way I like to say it, and this would be good for you to kind of think about as well, how many x's do the 2 terms have in common, right? Like, for instance here, 4 was the highest thing I could take out. 8 goes into 24, but 8 doesn't go into 4, right? Because 4 is not big enough. So same thing here. If I have 3 x's over here and 2 x's on the right, what's the most x's that I could take out? 2, right? And so we would say x squared would be the most x's that they have in common. And then we have 2 y's and we have 1 y. And we would say, how many y's can we take out? And remember, this is assumed to be a 1 right here. So that would just be a y. So 4x squared y is our GCF. In a little bit, we're actually going to take the GCF out and we're going to factor it out and see what we have left. But for right now, the first couple of problems that you're going to see on your assignment are just going to say, what is the GCF? Just so you can kind of practice taking the GCF out. Another one that's a little bit weird or different . And the reason why this one's a little bit different is because when we look at this, a lot of people think, oh, I'm going to distribute the 5 or I'm going to distribute the 7. And we're really not distributing here. These are 2 completely different terms. We've got 5 and we got an a plus b. A plus b is all together. The parentheses keep it together. Here we had three different terms. We had a 4, we had an x, and we had a y. Here I have a 5 and I have an a plus b. Here I have a 7 and I have an a plus b. So if I said what is a common factor that both of these terms would have, what would we say? A plus b. Okay? Nothing goes into 5 and 7 other than 1. So there's not really anything that we need to say for that. A plus b is my common factor. Do you have to put it in parentheses? Not necessarily. If you want to, that's fine. But because there's nothing in front of it, we don't necessarily need to put a parenthesis around it. You could just say A plus B. Okay. If I had like a 5 and a 10 right here, then it would be 5 parenthesis A plus B, because 5 goes into both 5 and 10. But because nothing goes into 5 and 7 other than 1, then we don't need to put a number out in front. You can put 1 if you want to, but it's assumed to be there, so we don't need to put it. Okay, so you'll have a couple of problems where you're just identifying the GCF. Some of them are going to be a little bit different, like the second one we did, where it's not just a number and some variables attached to each other. Okay, so then we're just going to talk about the factoring part of it. Okay, and today we're really just looking at GCF. And there'll be another one that we're going to do here in a second, another method that kind of goes along with factoring by GCF. But the first couple that we're going to do are just going to be GCF type problems. Okay, the first thing that we always will do is we're going to figure out what is the GCF, okay? And we got to figure out what that GCF is. So we look at the two terms. Here, they have a minus sign in between. A second ago, I just put two separate terms. They weren't connected together by any signs, and we just were finding the GCF. But here, because we have a minus sign in between, we're going to factor out the GCF. So as I look at 15 and 20, what would be the highest thing that would go into both 15 and 20? 5. Okay, so 5 is what we're going to start with. Okay, and then C's. I have 4 C's in the first term. I have 2 C's in the second term. How many C's do they have in common? 2. The first term has a D. The second term does not have a D. So do they have a D in common? No. So we can't take a D out. If there's no D, we can't take a D out. Okay? That's the way you want to think about it. Okay, now we're not just finding the GCF. Now we're going to take that GCF and we're going to factor it out of the terms that I have. And when we do this, I like to put it underneath both of these just so we can kind of see what's happening here. And this is kind of where it goes back to what we did last chapter as well. We're dividing these terms both by the GCF that I'm taking out. So when I divide this, 15 divided by 5 would be 3. We have 4 C's, but we're taking 2 C's away. So that would be C squared D. Keep the sign in the middle the same, minus. And then 20 divided by 5 would be 4. I have 2 C's, but I'm taking them both away. And so 4 is all I got left. And that is our answer. And not that we have to do this, but if I were to take this and distribute it back through here, it would get me back to where I started, right? And that's where the two are kind of associated with one another, and that's kind of how it'll work out. Okay, let's do one that has 3 terms. (25xy minus 50xz plus 100x squared). Remember to always take out the biggest thing that we can take out. 25, 50, and 100. What can we what's the highest thing we could take out?
25.
25. Yep. you don't necessarily have to write GCF here, but I like to just write GCF because that goes out in front. Okay, and then we look at variables. Do all of the terms have an x? Yeah, so we can take out an x. Do all the terms have a y? No. Do they all have a z? No. So x is the only variable I can take out, and I can only take out one of them because these two terms only have one x, this one has two x's. So we got to take out the lowest, essentially, that they all have in common. So we're going to take 25x out. And once again, as you get better and better at this, do you have to necessarily write it underneath like this? Probably not. But just remember that that's what we're doing. We're dividing each one of these terms individually by 25x, right? And we're taking that 25x out. But when we take it out, we're dividing it. That's why I like to put it underneath. So 25 divided by 25 would just be 1. My x's are gone, my 25's are gone. All that I'm left with here is y. Everything else is taken out. Minus sign. 50 divided by 25 is 2. The x's are going to disappear in z. Plus, and then 100 divided by 25 is 4. We had 2 x's, but we took 1 away. So we're left with an x. One way to kind of check to see if I'm really done is when I look at the 3 terms here on the inside, do those 3 terms have anything in common? And they shouldn't, right? Because if I've taken out the biggest thing that I can possibly take out, these 3 terms no longer should have anything in common. If they still have something in common, like let's say I only took out a 5, then they would still have a 5 in common because I didn't take out enough. Okay, so always look at the term when you have whatever's left over on the inside of the parentheses. And as long as those 3 don't have anything in common, then we should be in pretty good shape. So that's factoring by GCF. The other method that we're going to do is to factor by grouping. And in order to do factor by grouping, you have to have 4 terms. Okay. And that doesn't mean that GCF is totally out of the picture either. And as we get more and more methods throughout the sections that we do, we're going to kind of focus on like what's the process. You know, if I have 3 terms, these are the things that I can do. If I have 2 terms, these are the things that I can do. If I have 4 terms. So how many terms is going to determine what method is going to probably be the best. But no matter how many terms I have, GCF is always going to be the first thing that I look at. That's why we're starting with that today. All right, so let's start with an example of factor by grouping. Okay, the first thing we always want to look for, no matter what, is do we have a GCF of all 4 terms? Do all 4 terms have anything in common? No. Okay. We've got some A's, we got some Y's, we got some B's, we got some X's, but we don't have anything that all 4 terms have in common. Okay, so there is no GCF. So GCF is out the door on this one. So we call this factor by grouping because we're going to group this into 2 groups of 2. First 2, second 2. As long as they have something that we can take out. If not, we could rearrange them sometimes even. But in this case, out of the first 2, what do they have in common? An A. So we can take an A out. And if I take an A out, that leaves me an X plus Y. Out of the second group, we could take out a B, which leaves me X plus Y. And then as I look at the 2 parentheses must be the same. If they're not the same, then either I've done something wrong or I can't factor by group. Okay, but they should be the same. And as long as they're the same, then we're going to put these two together. A plus B, whatever's on the outside. And we're only going to leave x plus y one time. So as long as these two are together, we're going to put that as our second factor. Okay, this is our answer. If I were to FOIL this, is this just good old FOIL from last chapter? Then it would get me back to what I started with. Okay. Once again, not that you have to FOIL it, but that's how you could check it. That's how they're kind of connected to one another. Last chapter we did the foiling and we got the big long polynomial as our answer. Now they give us the big long polynomial and we're just going the opposite direction. That's all it is. Okay, let's do another one. This time we have some numbers in it. You got to kind of watch the signs, but don't forget the first step, because I'm going to give you one here in just a second that's a little bit different, but the first step is to always look at all four terms and ask ourselves, do we have something in common between all four terms? And here we don't, okay? We have some H's, we have some K's, we have some numbers, but nothing has all that I can take out of all four. So because we have four terms, then I'm going to try to group two groups of two. And then we look at the first two. And what do the first two have in common? H. So we're going to take an H out. And that leaves me H plus 8. Okay, what about the second group? K. Not only can we take a K out, but what else do they both have in common? A negative. So when we take something out here, we're actually going to take out a negative K. And we want to take out a negative here because remember that we're dividing both of these terms by a negative K. And when I take a negative divided by a negative, what do I get? Positive. So we have a positive H, and then a negative 8K divided by a negative K will be positive 8. These two must be exactly the same thing. They have to be the same sign, same terms, everything about them has to be the same. If one was a positive and one was a negative, then I've done something wrong, or we can't do it, okay? Because they're both H plus 8s, then that's good news, right? So we're going to combine the outsides together as our first term, and then leave the inside. 8 plus 8. Okay. And if you wanted to check it, if I foiled this, it should get me back to what I started with at the beginning. All right, we got one more to talk about. On this last one here, once again, we got four terms. But here's one of the reasons why we always want to look at GCF first. As I look at all four terms, I want to see if they have something in common. So as I look at all four, what do they have in common? 2's. Okay? So what we're going to do to begin is we're going to take out a 2. So we're going to do GCF like we did. Okay? Because all four terms have that in common. So this is going to be AB plus BX minus AC minus CX. We take a 2 out of all of those terms. Okay, that doesn't mean we're done, right? Just because we take a GCF out, and that's going to be one thing we're going to continue to talk about as we go throughout the chapter. Just because we've taken a GCF out doesn't mean we're done. we got to see if there's anything else that we can do. So can I continue this by grouping? So now we're going to take what's on the inside and we're going to group it. We have 4 terms. Maybe I can, maybe I can't. Maybe all I can do is take a 2 out. That may be the only thing I could do here. But we got to check to see if we can do grouping. So out of the first 2, I can take out a B. And that leaves me A plus X. Out of the second 2, what can I take out? Okay. And not only is C, but because they're both negative, I'm going to take out a negative C. And that leaves me a positive A, because a negative divided by a negative is a positive. And then a negative divided by a negative is positive X. So we're going to combine the outsides, B minus C, leave the inside, A plus X, and then we got to bring this 2 down and put it out in front. Because that was part of our factor, right? We took a 2 out at the very beginning, so we have to include that as part of our answer. So don't forget to put that 2 on there as part of your answer. So on that one, we did a GCF and we did grouping. We did both. So those are the only 2 methods that we're doing today, GCF and grouping. And some might have both in it as well. I don't think you're going to have any like this, but if you ever had something, if I gave you a number like 7 and I asked you to write the factors of 7, what are the factors of 7? 1 and 7. And so we say that this is a prime number. So if I had 3 terms that are just kind of like random terms that I can't factor, then we would say this polynomial is a prime polynomial because there's nothing we can do. Okay? So right now, I don't know if you have any like that today, but there could be some down the road where we might see that. And so just kind of giving you a heads up on that. Because if there's nothing that we can take out and no way that we can factor it, kind of like 7, we can't factor it, we call it a prime number, then we can do the same thing for a polynomial. Okay. Going by 4s, you can skip numbers 18 and 60. And I don't think 60 would have been, I guess if we're going by 4s, then 60 wouldn't be on there. So you can skip number 18. Okay. I'm going to bring your tests around, let you see those.